All right, hello everybody. Coming at you here with free response question week 2 recap. My goal here is to make this one a lot shorter than the last one, so let's get going right away. First off, we'll talk about real quick what's a good score. Okay, how do you know you're doing well with these questions we're giving you here? What's going to be a good score on the exam? And then we'll get into the specific questions, talk about the cheat sheet a little bit. Let's get going. Okay, so first off, what is a good score? Basically, on a normal exam, a single free response question makes up 1/8 of your total grade. So if we scale the usually out of 80 points down to a 9-point test, this would be how it's scored, or this would be kind of a pacing for an AP score. So for example, if you scored a 7 on all your free response questions out of 9, you'd be on pace for a 5. Okay, so 7 to 9 gives you the 5, 5 to 6 gives you the 4. Okay, so that's half the question right, basically. Okay, 3 with a 4. So we've been doing this all year long. I've been curving tests just to get you used to tests that you're not going to do perfectly. Okay, something to think about as you're going through these questions, as you're kind of in the heat of the moment with the timing. You don't need to be perfect. Get the points you can, and that's kind of what you're shooting for here. Okay, now if I double that for the 2 free response questions, which is what you're going to have on the test, this is basically what you're looking for. Okay, your raw score, the total points you get out of the 1 through 5 scale. Okay, and if I take all the kind of completed exams students have done the last 2 weeks where they've taken both questions 1 and 2, this is our breakdown. This is how we've ended up on this graph here. Okay, so doing pretty well. Now, I think the spot we can improve is, well, obviously, these are the areas we want to improve, because remember, a 5 or a 4 is for sure going to get you college credit, whereas a 3, maybe it depends on the school we're talking about. So we want to get into that 5 and 4 range. A lot of students who fell in this range here were doing great, except for one part of a question, they got a 0 out of 4, okay, or a 1 out of 5. And that's really the big thing to avoid is, again, you're not going to know how to do everything on here. Okay, you might, but, with the timing, you might not get it perfect. We want to talk about some ways to get it so that we're not completely bombing parts. We're just losing some points for different pieces we don't know. Okay, and as we're going through here, I've got students who were perfect for like 3 out of the 4 questions and then bombed one of them. That question just didn't make sense to them. Okay, the more of these you see, the better at you're going to get with them. Just the more experience, like with anything, the better you're going to do. Okay, we still have 3 weeks, so basically 3 practice tests to take before that actual test. Now, I guess as far as scoring this year goes, it's not gonna, I don't believe it's gonna be quite 2 9-point questions. Here's why. Okay, you're gonna get 2 questions on your exam. One of them is gonna be the FRQ3, the array/array list. That's the type of question we're practicing. Okay, that's going to be worth 65% of your score, and you get 25 minutes to take it. Okay, usually you get 22.5 minutes per free response question. So basically that tells me that you're going to get this full normal question, its entirety. But then for FRQ1, the method control structures problem, the other one we're practicing, that's only worth 35% of your score, and you're only getting 15 minutes for that. Okay, so that kind of leads me to believe that you're not going to be quite given a full-length normal test methods and control structures question. Okay, so for example, if a question usually has parts like A, B, and C, maybe it's just part A and B you're asked, or maybe it's just part A. So I'd imagine this would be out of 9 points, and this would be something more like out of 6 points. Okay, but I'm going to still give you the full-length ones. But yeah, like I said, on the test, it'll probably be a little bit smaller. Okay, if I figure out any other ways that they're adjusting that, I'll let you know. But just disclaimer, you're probably not even getting 2 full questions, probably a question and like a 2/3 of a question. All right, so let's get into the actual questions you work through. Again, like I said last time, if you stunk it up, pull the question up on Moodle, get your notes out, pause the video or rewind the video, make sure you understand this stuff. If you ace the problem, kick back, eat some popcorn. I would recommend still watching this. We'll talk about a few things, but you have a little less work to do if you're doing well with these. Okay, first one, the methods control structures question, talking about check digits. Okay, a check digit is used to help detect if an error has occurred when a number is entered or transmitted electronically. Okay, this is something that actually happens basically anytime something's sent over the internet. Okay, information sent. Okay, along with the chunk of information, there's usually an extra piece, okay, to kind of let you confirm that that information got there correctly. If that extra piece was missing or wasn't adding up to the stuff before that, you know, the servers would ask for that info again. Okay, so something happens on the internet all the time here. We'll give you the class, and one of the big things I want to focus on this week was calling methods, the method call part of it. We weren't perfect with it. That should be one of the easier parts of these. But if you notice, both these free response questions for this week, you're calling a ton of methods that you both wrote, and then they were also just written for you. Okay, so for the check digit, we're going to do the get check method. We're going to get the num with check digit is valid. I shouldn't have. Yep, whoops, I'm reading the wrong thing. The is valid method. And then again, we're going to use some methods already made for us, the get number of digits and the get digit methods. Okay, so part A, I don't want to read all this. Okay, so basically it gives you the way to find the check digits. I've got all that info here. If you need to pause to read through, you can. But basically what I'm going to do is I'm going to take each of those digits and multiply them by numbers. So the first digit's multiplied by 7, second digit's multiplied by 6, third digit, the 8's multiplied by the 5, last digit's multiplied by 4, and we continue that pattern down. We then add all those parts together, and then the check digit is the last number in that sum. Okay, and with that, we've got, I didn't want to do that. I want to do that. With that, we've got two helper methods. The get number of digits, which returns the number of digits in its int parameter. Okay, so if I plug that into that method, it'll give me the number of digits back. And then also the get digit, which returns the nth digit of its parameter. So write the check digit method. I guess here's something I really want to highlight. You must use get number of digits and get digit, okay, to receive full points for this one. All right, that's something to look for on the exam. That's part of the reason that I'm throwing these questions at you to get you used to that. Is if it says you got to use the methods, you got to make sure that your design uses those methods. I did have a lot of students for both this question and the last one not use those, try to basically recreate those methods and made mistakes, whereas just calling a method would have got them the points. All right, so let's start walking through writing that first method, public static int get check. Okay, so I want to get the check digit of the number parameter I plug in. Okay, well, first thing we need is a sum. Okay, we'll say int sum equals 0. This is where we're going to total things up to. And then what we're going to do is we're going to loop through every digit in that number. So I'm going to set a loop from int I equals 1 to I less than or equal to get number of digits num. There's my call to get number of digits. So in other words, I want the loop to go from I to however many digits that number has I pass in. Biggest mistake I saw on this one was a bad loop, something like this, starting at I equals 0. Okay, staying less than the number of digits. Again, a big thing to watch for, and as I teach this class next year, I'm going to make sure that we're not always looping all the way through arrays. Don't fall into that array pattern going from 0 to less than length. Okay, especially if you're not dealing, if you have a problem that has nothing to do with arrays, make sure you're not looping through that way. Okay, so we want to start with the first digit. We want to go until we're equal to the last digit, okay, the number of digits. And if you get that part, this question really isn't too bad. We'll add to the sum the get digit, and get digit returns the ith digit of the num we passed in. Okay, so we're going to add the ith digit of the num passed in times, okay, there's a couple ways to do this. We want to multiply the first one by 7, then the next one by 6, then by 5, then by 4, then by 3, by 2, 1. Okay, the trick I use, and this is the way the AP exam kind of gave their answer, was if we go 8 minus I, as I increases, that's going to decrease the number that we're multiplying by every time. So in the case of I is 1, this would be a 7. When I is 2, it would be a 6. Okay, a way a lot of students did it, though, that I like better is they made a separate variable for multiplication, They then said sum plus equals the get digit num at I times mult, and then counted down with a multiplication each time. Either one of those ways work. Okay, then last step, I want to return the last digit, okay, of that sum I just made up. Okay, so we'll go return get digit sum, and then the way to get the last digit is just get number of digits sum. Okay, use that method once again there. I guess other mistake I saw with this one is students were thinking of strings basically as zero index. I saw a few students kind of mix in the length method on this one. Yep, I guess just kind of watch for that stuff. Make sure you're not mixing up strings and stuff like that. Okay, part B, we're doing the is valid method. Okay, I'm going to say that a number with a check digit is valid if the last digit is the check digit of the rest of the number. So for example, if I do get check, the method we just wrote of 15159, it returns a 2. That's my check digit. Okay, so 1592 would be a valid number with a check digit. Okay, because the 2 at the end, the check digit, is the check digit of 159, whereas this one would be false. Okay, 3 is not the check digit of 159, 2 is. Okay, so we want to basically make sure that the method we just wrote returns the check digit of this 159 is just whatever this last number is. Okay, so let's do that. So essentially the big part of this question is taking the number that's passed in, the number with check digit, and breaking it down into two different parts. Okay, so first thing I can do is get the check number, the end of the number. Okay, and the trick for that is we can say int check equals the number with check digit mod 10. Anytime you do something mod 10, that's going to give you the remainder of when I divide by 10, so in other words, the last digit. Okay, and then what I want to do is I suppose I could use my get digit method as well, but we'll stick with this part here. Then what I want to do is I want to get the number without that last digit. Okay, so I'll just call that num. Remember, the way to lose the last digit is just to divide the number by 10. Okay, since we're talking integer division, that's going to truncate everything after that before the last digit. Okay, so what I have between the two of these is check will be my last number, and num will be everything before the check. And then last thing I'm going to do is make a new check. Let's figure out what the actual check digit of the num we just made is. So we'll call our get check method. And then what I can do is I can check and see is if the check, the last digit, okay, in that number with check digit, is equal to the check on the rest of the digits. If it is, we'll return true. If not, we'll just return false. Okay, big thing I want to kind of review and add your cheat sheet from that one is how to break up a number into its digits. Okay, that's something that is very common in an AP exam and also something that needs to be pretty automatic. Okay, I saw students kind of make that way more complicated than it need to be. Let's say I have some int 1, 2, 3, 4, 5. I can use mod 10 to get the last digit of that int. So for example, if I say int last equals num mod 10, that assigns the 5 to last. Okay, that's going to give me this 5 at the end here. I can use division by 10 to remove the last digit. So if I say int first part equals num divided by a 10, that's going to assign the 1, 2, 3, 4 to the first part. Okay, when I divide this number by the 10 with integer division, it's just going to get rid of this 5 and give me what's left. Okay, that's really the one part that I'd say to study and memorize from this question. Throughout the next week, I'm going to throw some stuff at you like this. Can't guarantee it's going to be on the actual exam, but it's something that's very common and something that should be pretty automatic for you, breaking numbers down. All right, our second question was the mountain question. Okay, we're going to say an array of positive integer values has the mountain property if the elements are ordered such that successive values increase until a maximum, the peak, is reached, and then successive values are decreased. Okay, so we'd say numbers have a mountain as long as it's increasing to a point then going down, which makes sense. we've got our different methods. So it gives you the is increasing method and is decreasing helper methods. And one weird thing about this problem is it didn't explain those very well. Okay, I thought about explaining more for you, but I figured giving me the AP style. Basically, they just tell you if something's increasing or decreasing. So increasing to a stop value or decreasing from a start value. And then we're going to write the get peak index method and the is mountain method. We don't need that. All right, so I'm going to say a peak is defined as an element whose value is greater than the value of the element immediately before it and is also greater than the value of the element immediately after it. Okay, so we've got some different arrays. We'd say that 33 is the peak, okay, at index 2 because before and after are less than it. In this case, we could say that 22 is the peak, okay, because before or after is less than or equal to. I suppose we'll include that. I'm going to say this one has no peak because there's no number that tops out above both the ones next to it. Same thing with this one. Okay, this one here we'd say 77 is the peak, even though it's not the maximum here. Okay, 99 is greater than it, but there's nothing on the left side of 99 for it to be greater than. All right, that's why the 77 is the peak here. The big thing with this question, I think, is this is a lot like finding a maximum. We've done that a lot, but it's not quite asking for the same thing. So make sure before you start that question, do take a few minutes, read through the problem thoroughly, make sure you understand what they mean by peak. Make sure it's not what you'd be thinking of as peak. Okay, so read it, think about those things before you start the question. Okay, so to do that, basically we want to loop through the array looking for peaks. Okay, we'll return that index. All right, so once again, one spot I saw students struggle with was getting this loop header correct. Again, this week, since we struggled last week, I picked some loops that weren't just 0 to length. Okay, with this one, I've got to start at 1 and go up until 1 less than the length. Okay, and the reason I need to do that is what I'm looking to do here is I want to compare the ith element with the one before it and the one after it. So if I started with I equals 0, when I did this I minus 1, we'd be talking the index at -1 that doesn't exist, we'd be out of bounds. Same thing here, if I went all the way to less than the length, which would be the last index, and I said that last index plus 1, that'd take me out of bounds as well. Okay, that's why I need to make the adjustment on that loop header once again. Okay, so again, it's something we struggled with last week, struggled with a little bit still this week. Just get used to that. It's not always 0 to length. There's different ways we can mix it up. Okay, and then basically from there, if this condition's true, we're just going to return I. We're going to return that index. Now, trick with this one is it just wants to know the first peak, the index of the first peak. So what I have to do is I have to kill this method. If I find a peak, I don't want to keep looking. I want to kill it and be done with it there. Okay, and then just something to watch for. This is always going to be worth a point. Even if you screw everything else up, if at the end of it you return a -1 because things aren't found, you get a point for that. Okay, so if I don't ever return an I because I don't find a peak, I want to return the -1. Okay, some students took kind of a little bit of a different approach, and I want to show you how you can get lost with this a little bit. And it all popped up for me at once. Oh well. A few students kind of defined a variable as for the index that I'm looking for, and they started with -1. Okay, makes sense. We'll then loop through the entire array looking to see if we find a peak. If we do, we'll assign that I to the peak and return the peak at the end. Okay, so if we find the peak and return it. If we don't find anything, we'll return the -1. Now, the one trick I'd need if I do things this way is a break statement. Okay, obviously I don't have to do things this way, but if I wanted to make this work, I would need that break because we just want the first peak. I don't want to go looking for a second peak or a third peak, so I would need that break. Remember, what break does is it stops the loop dead in its tracks. So if I reassign peak to the ith index, we'd break out of there. I'd then return that I that I got there. Okay, so I want to point that out because a few students try to do it with the variable method. You just need a break statement. Or I suppose I could just say return I right here. Or return peak right here. But either way, we need to break out of that loop. All right, then the last one we have is the isMount method. Okay, and what that's essentially going to do is utilize the getPeak method to determine if an array is a mountain. Okay, again, I can think of other ways I could design this code, but part of the reason we're practicing this one is AP is going to ask you to do things their way, and that's kind of what we're practicing doing. Okay, so the values array orders a mountain if all three conditions hold true. Okay, there is one, a peak. Okay, everything smaller than the peak must be increasing. So that's where the is increasing method is going to come into play. And then everything after the peak is decreasing. That's where the is decreasing method is going to come into play. So we'll have to call those to get full credits for this one. And then it gives us some examples of mountains. So for example, first one, it would be a true. It is a mountain because there is a peak in the middle and it's increasing to that peak, decreasing away from it. This is false. There is a peak, all right, but it decreases, increases, decreases. Okay, we got to be increasing to the peak, decreasing after it. And then there's a few other examples here. This should say true. My bad as I look at it here quick. Okay, so that should be a true one. But as you're going through these, do take a minute. Make sure you understand what they're asking for. Make sure you understand, how this method's supposed to work. That's going to help you write it. And then complete the isMount method. And again, use the getPeak index, is increasing, is decreasing. Something we're practicing here today, calling both methods we've already written and methods they gave for us. All right, so let's write that method. Public static boolean isMountain int array as a parameter. I guess first thing with that I'd recommend is figure out where that peak is right off the bat. Okay, I could just plug this getPeak index of array into my different conditionals, but this is one case where it's going to be a lot easier if I just have that as a variable stored right away. And then I can do this all as a single conditional. I can say that if the peak is greater than -1 and is increasing array to peak, so this array is increasing from the start of the array to the peak and is decreasing array to peak. Okay, I can plug that all into a single conditional and I'm basically done. If that conditional is true, we return true, or else we return false. Okay, now there is one detail happening with this that a few students mixed. As far as the order of this compound boolean goes, I have to have the peak greater than -1 first. Okay, reason for that is if it's not greater than -1, let's say the peak is -1, when I plug that into these next two methods here, we'd be out of bounds with an index of -1. Okay, so the way we're getting around that here is with what Java does called short circuit evaluation. When you make a compound conditional, if the first part of it's false, okay, so if Java knows that after reading this first condition, the rest is going to be false because it's all ands, it won't bother to go ahead and plug the peak into these other parts. It won't evaluate the rest of the expression. Okay, so that is something you have to think about as you're dealing with multiple conditions. I need to make sure I line them up in an order where that, if there's a condition that has to be true for other methods to run, I need to check on that condition first before I try to check those other methods. And here's an example of doing that with short circuit evaluation. Again, if my peak is -1, these other method calls Java won't get to those methods. Okay, I want to show you a different way you can design this. So same idea, we've got that peak index. I could break this into separate conditionals. So we can start off with if peak is greater than -1. Okay, if it is, then we'll check and see if it's increasing and decreasing. Okay, so if it is greater than -1, and if it is increasing and decreasing, we'll return true. I want to highlight this for you because it's kind of an interesting conditional. Or else I need to return false within the first branch of this main conditional. If the peak is not -1, I'll return false. So with here, I'd say else and a return false. Now, if I'm going to do it this way, I do need all three of these parts. Okay, because if this isn't true, so if the first condition's true, but this one isn't, I need this extra else to get to this false thing at the end. Okay, when you're writing a method that's supposed to return a Boolean, okay, or anything really, you need to make sure that your method will get to a return statement some way, shape, or form. It's not a correct method if there's a return statement that's not reached. Okay, I suppose for this one, kind of a catch-all you could use is you could say if peak is greater than -1, if is increasing and decreasing, return true, and that's it for your condition, and then just have a return false at the end. Okay, I did want to show it this way because some students tried to design it with a chain of conditionals, but they kind of never got to return statement. All right, so that's it for this review. I don't really have anything cheat sheet worthy for you from the last question there. Okay, we did cover a lot. We talked about a lot. We went through a lot really quickly. Okay, there wouldn't be time in the 5 weeks to make a slide about every detail we went through with these questions. So watch the video. If you need to listen to a part again, do that. Or if there's something that still isn't making sense, Mr. Bailey, you talked about short circuit evaluation, but I don't quite get that all the way. Shoot out an email, meet me on my office hours, we can go more in depth to that kind of stuff. Okay, because really that's what you want to focus on, the stuff you don't get. That's why we're doing things this way. I don't want to spend a ton of time reviewing the stuff we are doing well with. I want to highlight the stuff that we don't get, and if you still don't get it, make sure you're putting some time in. Okay, so hopefully that helped. Like I said, reach out if stuff still isn't making sense.